Hello there. In this video, we are going to see how to declare an array, initialize, and iterate through it. So, an array is a collection of similar data type. So, in array, we can store one or more data together. So as we declare a normal data type, we can declare an array also. So an array requires identifier name as well as a data type. We already know that all array elements falls under a single data type. That means if we declare an array, it is not possible to have 10 elements integer and 10 elements decimal. So either all elements should be integer or it should be float or other data type. So here is an example of declaring an array. So if it is a normal variable declaration, we will not be having the opening and closing square brackets. So this opening and square bracket differentiates the declaration of normal variable with array variable. Here numbers is array variable. You can also notice the location of open and close parentheses. There are two alternatives. We can keep it after the data type, which is shown here in the second line, second statement, or we can even place it after the identifier name. So yeah, the above syntax shows a two way of declaring an array. In the above statement, the data type is integer, the identifier name is numbers. So when we call the array, here it is a numbers array, data type is integer. So once we declare an array like as shown in the above syntax, in stack frame we will get a slot for the identifier numbers. So we can reach the array based on the identifier numbers, but it is pointing to null because we haven't specified the size of the array here. In the above statement, we just declared an array. Since size is not specified, no memory is allocated for it. That's how we can still reach the array numbers, but it doesn't have any data associated to it so far. Yep. The picture shows an empty slot, and that empty slot is reachable by numbers, but it doesn't have any memory allocated, or array is not yet alive. So previously we saw a declaration, here also a declaration. Here we created an array and we also allocated space for the array. So after the equal to, we have a keyword called new, then we specified integer of 3. So that's how we read new int of 3. So the square bracket, we read it as int of 3. That means a 3 slot for integer. Once we declare like this, we will have a slot in a stack frame numbers, then we will have 3 slots. Since it's a primitive data type, we have a 3 slot in the free store, and each will have a value in it. So the picture beside shows how these slots are created. If you see here, the number is reachable in the stack frame, and that number points to a heap which has 3 locations. So in each location we have a value 0. Since we doesn't specify initial value, Java allocates memory. After that it initializes with the default 0. So here we allocated 3 slots, and each slot is reachable by an index number. So in the upper picture you can see each slot is having its own index. The index starts from 0, then it increments. So since this is integer data type, we have 0. For other data types, the defaults are shown here in the table. Integer will hold 0, booleans will hold false, character variables hold empty if it is not initialized, and in an array we can store object also. The object will store null if it is not initialized. So for other data types you can experiment. If it is decimal, you will have 0 again with a the value will be like a 0.0 like that. So other data type you can examine yourself. So the operator open and close bracket is called an indexing operator. So based on this indexing operator, we can retrieve an element from particular slot in an array. In the below example, we are accessing the array numbers based on the index 0, 1, 2. So in the previous slide, we saw that the array is declared and size is defined. Simply speaking, array of 3 integer is declared, and each element is having the default value of 0. The below statement now assigns value to each slot. That means we are accessing the array numbers based on the indexing operator. Here we accessed all 3 elements of the array based on the index number 0, 1, 2, and assigned values of 5, 10, 15 to it. So after the statement here, we can see that the slot got changed from 0 to these values 5, 10, 15. So the array at element index 0 is 5, and like that the array at element 2 is having the value of 15. In the below statement, we are actually reading the content from the populated array. Here, since we are keeping it on the right side of the equal to, the value is read from numbers of 1. That means an array at second slot, that means it is identified by the index 1. The value is 10 here, that is read and assigned to the integer variable x. So this is reading the data. So reading and writing both are done through the indexing operator and index value placed in between the square brackets. So we can also declare as well as initialize. In the previous statement, we declared an array and we allocated 3 slots. After that, we initialized it based on the assignment statement. The 3 statement in the above example shows the assignment, but we can declare as well as initialize the array. Here in the below statement, the value placed in curly braces not only allocates the space, that means here the compiler says it needs to allocate cell for 3 values, and based on the array declaration it knows the data type is integer. Based on the value within the curly braces, it knows it needs to allocate 3 slot. So after allocating the 3 slot, it will place these values 10, 11, 15 into the slot. 10 goes to 0th index, 11 goes to first index, and 15 goes to second index. So the below picture shows declaring as well as initializing the array, and each slot got filled after executing that on single statement. Let us see an example. Here in this example, we declared array int numbers, and within curly braces we placed 4 values. So this statement creates an array with a 4 slot. Then in each slot we place value of 5, 10, 15 and 20. Then in the sample 2 part, code snippet 2, we read 2 array elements. So first we read the element at index 0. That means the first from first location of array we read the value. Then in the next system.out.println statement we read third value. So third value means index at 2. Since index starts from 0, if we need to get array at location 20, then in the index we have to pass 19, since the indexing starts from 0. Yes, here we declared an array, then we also initialized the value, then we read the 2 elements and printed it. So here in the example 2, array is declared and size is decided by the parameter. So here we don't know the size of the array because it is dynamic. Whoever calls the function, those decides the size of the array. So if the calling code calls a test array populate, and if it passes 10, then we are declaring an array of 10 integers. So it is decided at runtime. So after array is declared and the size is decided, we know that it will hold 0 in all elements. So we have to initialize those. So here in the sample 4 code snippet, we are using a for loop, then using the indexing operator, we populate the array. So we are populating the multiplication, the square value inside the array. We are multiplying the number with the same number. That means we are getting a square of the number and we are storing that inside the array. So here in the loop, you can see that the termination condition I less than x. So here we doesn't place I less than or equal to x because we know that array starts from index 0. So we have to stop our iteration just one number below. Suppose if the size of the array is 10, we have to stop our iteration at 9th. Why? Because the maximum index which we will have is 9 in case of a 10 size of array. Finally, we iterate through the populated array and we print the content in each element. So let us explore these two examples in Eclipse. So here we have our classes. First we will create a array X class. Okay, the project is ready. Then we will add our class. Here our class is ready. So in the slide we saw a first example. So we have created a test declare and init method inside the array X class. So whatever you saw on the slide, that's the code placed here. We will examine this, how it works. Then we will also check how to initialize an array. Allocate space dynamically. So here the X decides the size of the array. We will create our next class. The next class is array main. It needs a public static void main. We'll put a breakpoint so that you can see how array get initialized. Let me go through the breakpoint. We'll move to this. So first we created our example class array X. Then we will examine the array functionality one by one. First I'm getting inside. Here if you see, we are declaring an array and numbers is declared as well as initialized, size allocated and value initialized, and we can see this. There are 4 elements declared and value is specified here within curly braces. So this is at index 0, you can see it here, 5 at index 10, 10, 15, 20, so all get initialized. And if you see, the size of array is 4 and index starts from 0. So here in this statement we are reading the array element. So the first one we are claiming is the value at index 0. So number is the array. We are using the indexing operator, this one 0. So it retrieves 5 and prints that here in the console output. element at index 0 is 5. Similarly, when we need the last index in the array, I mean the third value in the array, we pass the index 2 to the array. So numbers of 2, value 15, that will get retrieved here and get printed. Alright, now we will check populating the array dynamically. Here if you see, we are passing the value of 5. That means we are asking to create an array with a size 5. That means the array can hold 5 integer. So if you see, the array is numbers, which is not yet created. Once we execute this statement, here we are allocating new, and we can see all default values here, 0. Then we are using the loop and populating it. So array is populated. After this, once again we are running the loop and reading the array based on the index, and we are printing the content. So next we are doing the same with array of 12 elements. This time I'm not going to step in, I'll step over so that you can see the output here. So this time it allocated 12 slots, and you are seeing the square of all 12. So that's the use of array. So thanks for watching the video, and the next video we will see how to create a two-dimensional array. So whatever you saw here in this video is a single dimension array. In the first example, we saw how to declare and initialize. Then we saw how to read a value from an array. In the second example, we saw how to create an array dynamically. Then we saw how Java assigns default value after the array slots are created. That proved us that we have to place values inside each cell after allocating the size of the array. So in the second example, we created the array slots dynamically based on the passed in parameter value. Then we populated it and printed the populated array. All right. Thanks again for watching. Bye.